Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on November 28, 2025, about 3 days ago. This paper introduces an edge-first family of liquid foundation models that match strong generative and multimodal capabilities, while running on phones and laptops, up to about 2 times faster for prefill and decode than similarly sized models on standard CPUs. The paper is titled LFM2 Technical Report, and as we will see later, the design choices here have big implications for how we train and deploy compact on-device models. Alright, the previous segment sketched why an edge-first design matters. Figure 1 now lays out what the LFM2 ecosystem actually includes. Panel A summarizes the portfolio, with dense backbones at several scales, a sparse mixture of experts model, multimodal variants for vision and audio, and task-specific models for retrieval and retrieval-augmented generation. Panel B shows the training taxonomy, where a shared LFM2 base branches into language, vision language, and audio families, plus smaller nanomodels specialized for tools, retrieval, and math. Well, Figure 2 shifts from the ecosystem to the core LFM2 block design, which explains how the models stay both fast and capable. The central stack shows repeated sequence blocks with normalization, and a feed-forward block wrapped in a residual shortcut. On the left, pink panels illustrate dense SWI-glue feed-forward layers, or an optional mixture of experts router that activates only a few experts. On the right, purple panels show the gated short convolution block and the grouped query attention block, which alternate to mix tokens efficiently with low compute cost. So, while Figure 2 described the building blocks, Table 1 spells out how those blocks scale across the concrete LFM2 models. The table lists model sizes from 350 million up to the 8.3 billion mixture of experts, along with layer counts and hidden dimensions. Backbone columns specify attention heads, key value groups, head size, and how many convolution and attention blocks appear. The final columns show mixture of expert settings, including experts per layer and how many experts fire for each token, which explains why the 8B variant reaches higher quality without paying full 8B compute every step. So, while Table 1 covered architecture choices, Table 2 shows how those choices translate into speed on a Samsung Galaxy S25 smartphone. The table reports prefill and decode tokens per second for different prompt lengths. LFM2 models consistently beat similarly sized baselines, with the 350 million model running about twice as fast as Granite 4.0 at prefill. Larger variants like LFM2 1.2 billion and 2.6 billion stay ahead as well, which confirms that the hybrid backbone really pays off on phone-class CPUs. Okay, while Table 2 focused on raw speed, Table 7 compares quality for small models between about 2 and 8 billion parameters. The first rows show that LFM2 8BA1B and LFM2 2.6B match or beat popular 3 to 7 billion baselines on knowledge tests like MMLU. Instruction following and mathematical reasoning blocks reveal especially strong gains on GSM 8K and related math suites, and the multilingual block shows competitive scores across languages despite the compact active parameter counts. So while Table 7 compared raw accuracy, Figure 4 shows how that accuracy trades off against speed on a phone-class device. The left panel plots pre-fill throughput at 4K tokens against average evaluation score, and the right panel does the same for decode throughput. Purple points for the LFM2 models trace a dashed Pareto frontier, which means no other model is both faster and more accurate at those points. The gray baselines mostly sit below or to the left, so they are either slower, weaker, or both. So stepping back, the big message is that edge-first models do not have to be weak. This family reaches mid-scale quality while staying roughly twice as fast on real phones. The broader implication is that serious language, vision, and audio assistants can increasingly run locally. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.